Hello, my name is Ash Stott from Eosphere, based in the UK. I'm working on a project called SIBELIUs, which aims to provide satellite-derived data, especially about pasture and agriculture, to help our herding and farming communities. In this video, I'd like to show you around the SIBELIUs visualization website, which has been designed to provide access to satellite-derived information and how this can be used for various different applications. The first thing you'll find on our website is a standard disclaimer form, which needs to be accepted. Navigating in the website is similar to navigating in any other web map-based facility, for example, zooming and panning. In the top right, there are 3 language options: English, Kyrgyz, and Russian. I'm going to select the English option. The opening image is an optical image, just like a photograph but acquired by satellites. This image is at a relatively low resolution, with pixels of 250 meters, which is a good resolution for looking at conditions across the whole country. The menu on the right shows the other products available. These include optical, pasture, snow, drought, and temperature. Let's take a closer look at the optical RGB data. We can see that this data is available in low and high resolution. The higher resolution products have pixels between 10 and 20 meters, while as mentioned, the low resolution products are at 250 meters. So you might ask, why would anyone prefer using low resolution data compared to higher resolution? The answer is that low resolution satellites acquire data much more frequently than higher resolution ones. So the lower resolution products are updated much more frequently, once every 10 days, compared to the higher resolution ones, which are only updated once a month. Also, it is often quite cloudy in Kyrgyzstan, so having more satellite data acquisitions gives us a better chance of being able to see through the clouds. If you click on these question marks, there is further information about the products, such as the satellites and their parameters. Let's have a look at some higher resolution data. This has a resolution of between 10 and 20 meters, depending on which product you're looking at. The grey areas show where the data is available, so as you can see, we've covered the whole of Kyrgyzstan. If we zoom in, we can see that the higher resolution data allows us to see what is happening on individual fields. Potentially, this could help with understanding if crops are being stressed, for example, because of a lack of rainfall, and therefore whether irrigation is required, or for predicting what the yield will be from each field. It is also possible to look at earlier conditions. If we go back to early January, we can see that as expected, there is widespread snow coverage. Understanding pasture conditions is very important for many people and institutions across Kyrgyzstan. So let's take a look at the pasture option. We have 4 main products: NDVI, pasture biomass, pasture anomaly, and pasture trend. NDVI provides us with a measure of the amount of greenness from vegetation on the ground. So this correlates very strongly with how much pasture or other types of vegetation there is. We can see that in September 2020, there is still a lot of vegetation across the whole country. Clicking on individual regions also gives a useful feature. In this chart, the vertical bars show how the pasture greenness values have progressed throughout the year. These can be compared against the blue line, which shows the historical average greenness for the same time of year, where the historical average has been calculated using the last 10 years of data. We see that the bars usually follow the historical average or are sometimes slightly above it. This indicates that it has generally been quite a good year for pasture conditions. Let's switch over to the NDVI anomaly option. This anomaly map shows how the current pasture conditions compare to the historical average for the same time of year. So this is exactly the same information we just saw in the greenness graphs, except that now it is in map format and for just one time of the year. The fact that this map is mostly green confirms that it has generally been a good year for pasture conditions. You can see that the lakes show up in red. This is an anomaly that we will mask out in the future. Also, some of the red that you see on the tops of mountains is probably more to do with changing snow conditions rather than actual pasture. In general, measuring vegetation using satellites is only really feasible outside of the winter months when the ground is free from snow cover. Let's have a look at some high-resolution pasture data. We can see that in this region, the current greenness values indicate that some fields still have vegetation, while most of them do not. And again, we can go back to an earlier date to see how the conditions have changed. If we go back to July 2020, we can see that there is much more green vegetation in evidence. Finally, let's take a trip to the Susamura Valley. The Susamura Valley is an important region for livestock herding. These darker regions are Karagana shrubs. Karagana are inedible shrubs which are spreading in many parts of Kyrgyzstan. Livestock animals cannot eat the Karagana, so this reduces the amount of available pasture. One of the great advantages of monitoring the environment using satellite data is that it allows you to easily assess how things are changing. For example, has the Karagana spread more this year compared to last year, or have attempts to remove it been successful? Of course, the impacts of climate change is another area in which satellite data can help in monitoring our environment. It is also useful to point out that the website has other map information, such as different regional boundaries, which are marked in red. We've tried to use the best information available for the boundaries, but this website should not be regarded as an accurate guide for where the boundaries lie. These are just here to help you find your way around. We also have a search facility for locating place names. Lastly, we have an export function. To use this, you'll first have to sign in, which you can do with a Google account if you have one. This will allow you to save products as PDF files, which of course you may wish to print. Hopefully this brief tour has shown you some examples of the sorts of applications that can be addressed using satellite Earth observation data. We hope you find many more. Thanks for watching.